Hi, my name is Joan Griswold from Genome Sciences Education Outreach Group at the University of Washington. And my colleague Atom Leishak and I are working on a program called GEMNet, which stands for Genes, the Environment, and Me, a Health and STEM Network. So through this program, we are looking for ways to explore gene-environment interactions, and we have chosen type 2 diabetes as the vehicle through which to do this because there are a lot of places to explore this. So what we have developed over the past number of years are two sister curricula that work together. One is for health classes and the other one is for biology classes. And they share a lot of concepts around environmental influences and glucose balance. And they share the same exact set of enduring understandings for both units, but we go about getting to those enduring understandings in a few different ways. The health classes focus more on nutrition and disease prevention, and the biology classes focus more on homeostasis, feedback mechanisms, and population genetics. So why type 2 diabetes? Well, it's a complex enough condition that there are so many different ways that you can go with it. And teachers have asked me, you know, I can teach homeostasis in 15 minutes, or give me a class period and I got this. Why should I spend a week and a half or 2 weeks with your curriculum? Well, first of all, we do address the biological concepts which are standard in a biology class, homeostasis and feedback mechanisms. What is glucose? Where does it come from? What else is it all about besides cellular respiration? How does the body balance glucose? We also get into the gene-environment interaction by thinking about how is this determined? What is the genetic component? What is the environmental component? And how do those interact with each other? And where a lot of curricula stop there, we go on in a number of different ways. We address some of the social factors that influence this condition. So how do we market foods and drinks? How are resources distributed? And then we go into the individual choices about diet and exercise and how do they matter and why do they matter and when do they matter? And then we point students towards thinking about treatments and solutions for this problem, this social problem that needs fixing. So how can we as an individual, as a group, stop the growth of this condition? And what should our priorities be? How are we going to weigh out harms and benefits and pluses and minuses for treatments and prevention? So during this short session, I will present the driving phenomenon that links both of our curricular units. We'll have a quick lesson overview, and then I'll show you how to access the lessons both online and if you're lucky enough to be in a traditional classroom, we've got lessons for you there too. So before we start, and we do this in the curriculum, we have students weigh in on two things. First of all, rank yourself on a scale from 1 being individuals to 10 being society. Do you think that solutions to the growth of type 2 diabetes are mostly with individuals or society? And I know it's not an either or, so it's some combination, but where do you think the weight mostly falls? And do you think that developing type 2 diabetes is mostly due to genes or environment? So think about those two things and write maybe your numbers down someplace because we will come back to that. All right, our driving phenomenon is a series of PowerPoint animated slides from the Center for Disease Control, and you're going to see a map of the United States get darker and darker. And I'm not going to say anything during the PowerPoint, just be thinking about what you're seeing and what questions this might bring up for you and your students. So what did you notice watching the map of the United States get darker and darker? Did you notice any geographical disparities? Do you notice things over time changing? This map does tie obesity, the changes in obesity rates with the change of diabetes rates because they are heavily correlated. And now's the time to ask your students why, what's going on here, and what are they thinking? So lesson one starts with this phenomenon, and then we have, actually, let me first show you the overview of the 5 lessons. These are the curriculum components. So we'll go very quickly through each one. So lesson one, after students see the map, they then go to the source of the data, which is the Diabetes Atlas from the CDC. This is a wonderful resource for students. If you go under state data to all states, you will see the map that we just saw, except in blue. And when students are here, they're taken through a number of steps, but it's just a great place to explore. You've got a time bar along the bottom that you can go back and forward in time. You have heat maps over here. You have a scale down here that changes depending on how you're sorting the data, which is an interesting way of thinking about scales. You can sort it on age and gender and education. So this is what students do during lesson one, is go here and actually look at the data in a little bit more detail. Not only that, you can then get state data, which breaks it out county by county. So that's a really interesting place to go, is to go to your home state and see, well, why is my county higher or lower than the county next door? So lesson two then is we start getting into glucose homeostasis, and lesson 2 and 3 are basically a chunk that go together, but we start thinking about glucose because students may have heard of it in the context of cellular respiration, or maybe you haven't gotten there yet in class, so this is a way of introducing glucose, because it's so important to things in our body, yet we rarely see it on a label. If you're eating or drinking something, you don't see glucose. So where is all of this glucose coming from? So students start with a folding kind of paper doll activity where they make glucose chains, and we talk about what is fiber, what are these polysaccharide chains, what is fiber and starches, when you eat a potato, what actually is in that, and then talking about how those glucose molecules break off of your starches and fibers. We talk about disaccharides, sucrose and lactose, and then finally get to glucose, the monosaccharide that is so important for type 2 diabetes and many other things, as you all know. So we introduce homeostasis as this thought of balancing, that if you have too much or too little, your blood glucose is going to tip in and out of a range. And if you have too high, then that starts insulin being released. If you have not enough, then you get glucagon being released. And students play around with a model board where they're using pasta pieces to actually simulate high and low blood glucose levels. So they go through 6 different scenarios. First, just modeling when glucose is well regulated, what happens. And then we model, insulin resistance, what does that do to our system? Oh, the pancreas is not producing enough insulin. What does that do to our system? We have a very sedentary lifestyle. What does exercise do to our system? What does weight gain do to our system? All sorts of perturbations to the basic system. Now, in an online form, students can't use the hands-on model board. If you're in class, let me know and I will send you a class set of 8. But at home, they can either watch me do it, which is not that exciting. They can print out their own DIY model board, and you don't need the exact same pieces of pasta that we use. You can use any little things to move around on the board, or you can have them do it in classes. We do have a PowerPoint model board that they can move around, but we're working on sort of gamifying this so that it's a little bit more accessible for an online situation. So then after that, we get to lesson 4. And this is the gene environment lesson where we really dig into what is your environment. And we're not talking about just the trees and the air around you, but we're talking about things like culture. So people consider that diabetes runs in families, and so they assume that it must be genetic. But culture also runs in families. The things that we do together, the ways that we eat, the ways that we celebrate, all sorts of things we learn from our cultures and our families. And does that impact your risk of type 2 diabetes? And so we have students think about that and watch some videos that really bring that to the forefront. And then they participate in an activity using beans and bags where they are drawing beans that represent alleles out of the bags. And it's a good place to talk about probability and introduce some terms if you would like.
How do genes influence a person's risk of getting type 2 diabetes?
Hi, I'm Joan from Genome Sciences Education Outreach. In this activity, students come up with a simulated genetic risk score for type 2 diabetes. Now, genes clearly play a part in developing type 2 diabetes, but there may be hundreds, if not thousands, of genes that contribute to this condition. So in this activity, students use an egg carton and different colored beans to come up with a simulated risk score and look at how genes might be distributed throughout a population. So the egg cartons represent 12 different genes that might contribute to type 2 diabetes, and each bean represents an allele. So the white beans are risk alleles, so the more white beans you have, the higher the risk, and the red beans are protective alleles. So if you have one of each, then that would be a 0 risk. 2 red beans is a -1 risk, and 2 white beans is a +1 risk. So once students fill up their egg containers, they then would figure out their risk score and write that on the student. So even though Mia and Maria were both drawing from the same bag of alleles, Maria got a -6 protective factor and Mia got a -1 protective factor. So they came up with very different genetic risk scores, which shows that even from the same population, you can be getting a random distribution of genes throughout that population. All right, so after students do this, they map or graph their risk scores. And after doing this with a number of students or a number of classes over time and making it additive, you start to see that you will build basically a distribution curve that is pretty standard, where most people are going to be around the middle with 0, -1, +1, and then some outliers. So this is helping us build a concept other than the Punnett square version of genetics. So in the past, I know you're all biology teachers and you look at this and think Punnett square, not tic-tac-toe. But in the past, we have done it in this way where we've talked about really discrete alleles and tied those to different medical or health conditions. And so this is problematic. It's not wrong for single gene traits, but most of the traits out there are not single gene traits. So if we start in them with Mendelian genetics, then we're really reinforcing these single gene conditions, which can lead to sort of a genetic predeterminism, where I've heard people say, well, it skips a generation. So my grandmother had it, my mom doesn't, but I'm going to get it. And so they're trying to take what they've learned from their Punnett square biology genetics classes and apply it to these very complex conditions. And it just, not only does it not work, but I think it can be harmful in some ways. And so we're trying to build an idea that for complex diseases, it's a variation in many, many, many genes that add or subtract to the risk of getting that condition. So the more risk alleles you might have for a condition, the higher the chance you're going to get that, but it's not a yes or no thing. It's along a curve, it's along a distribution curve. So that some people with a lot of high risk alleles might have type 2 diabetes, and some people with a lot of high risk alleles don't have it. And some people with low risk alleles combinations still get type 2 diabetes. So this is a much more complicated way of thinking about it, but more accurate for the kinds of diseases and conditions that are going to impact students and their families and their lives. You know, cancer, diabetes, heart disease, all of these are due to small changes in perhaps many, many genes. And there's, in some cases, there is one smoking gun gene that if you can go after that and get it, you can make an impact. But with diabetes, there's not. There are thousands of genes that contribute a little bit. So this brings us back to the environment. So we saw the map change over time, and if the genetics is due to many, many different allele combinations, it's really mediated by the environment. And how has our environment changed in the last 20, 25 years that has led to this epidemic of diabetes sweeping the country? And if genetics are was the only driver, why do these geographic disparities exist? Is this county have people that are that much genetically different from the county next door? No. And also, it is moving quickly enough that that's not really the hallmark of a genetic disease in the first place. So there's something about our environment that is changing over time. I'm almost of the thought that we are all predisposed to diabetes given the changes in our environment. So it's not so much like these people or that group of people are more predisposed. I think it's a human condition really, or else it would not be moving so quickly. At this point, students go in and take an environmental survey that is very fun and interactive. We'll do a couple of pieces of it. It's 25 questions, and for each question, students rate the number of fast food establishments, such as McDonald's or Burger King or convenience stores that are in your community. Your community is defined as about a 1 mile radius from your house or a 15-minute walk. And I live in Central Bellevue. I'm surrounded by fast food places. Each question is backed up by the data that we use to develop that question, so students can dig deeper into that. And then the number of times that you eat at a fast food restaurant over the course of the week. I do occasionally, so I'm a 0 to 1. So students go through 25 of these questions. Some are related to access, like is this thing near you and can you access it? And some are have to do with choice. So even though I'm surrounded by fast food restaurants, do I choose to eat there very often? And then at the end of this, you go through all of that, they would get a environmental risk score that is actually pretty accurate because it's not a simulation, it is their real environmental risk score. And I will have all of the links. If I know these links aren't live, I'll have them all at the end of this presentation so that you can find all of these. So then the last lesson, students are looking into the future. If current trends continue, 1 in 3 adults will have diabetes by 2050. So how old are your students going to be in 2050? I know it seems forever in the future, but at that point, would they be at risk for type 2 diabetes? And what could they do right now in their lives to mitigate that risk? So students in this lesson read about 5 different solutions that different countries or groups of people have come up with or tried. And then they're asked to come up with their own solution or build on one of the solutions that they've read about. And then they go through a pretty detailed planning sheet where they have to think about, well, how are you going to pay for this? Who is it going to impact? Who are the stakeholders? How will you know if your solution is working? And then they work through that by weighing out a lot of the different things that you need to factor in and coming up with a solution for pretty much anything. So now that you've seen this, we're going to come back to these first 2 questions. Which do you think that solutions to the growth of type 2 diabetes lie mostly with individuals and society? And then do you think it's mostly genetic or environmental? And we're trying to move the needle on these a little bit. I'm not sure where you started or where your students will start, but rather than thinking of type 2 diabetes, if you saw that's a totally individual mandate, because that's sort of how it's put out there. I would like to propose, and through the curriculum, I hope that we get to the point that there are a number of social, societal systems that are in place that can make it really, really hard for individuals to eat right and exercise and do the things that we know have an impact on diabetes. People haven't changed that much, but our environment has changed, and our social environments have changed in a way that it's really it's really made type 2 diabetes much more predominant. And so, yes, individuals obviously need to, there's some ownership there, but there are also things that we can do on a social level that might help. And again, most people come into this thinking that it's a very genetically driven disease, and we're trying to move the needle to see that there are many environmental factors that are playing a very important role here. Some happy feedback from teachers. So how do you access this? If you are in a traditional classroom, this tiny URL takes you to a Google folder. And in that folder, you have the PowerPoint that all of these have come from. You have the teacher information, which gives you more information than you'll ever want, or probably about how to teach this. It has all of the student handouts. It has the very specific ties to next generation science standards, all of the back-end material for teachers in a document that once upon a time you would print out and put in a 3-ring binder and put on your shelf. So we realize those days are coming to an end. So at Home Learning, we have another folder for you, and it leads you to a Google folder that will look like this. There are many documents in here. What we've done is turned each lesson into a student roadmap, so that when students are at home, they open this Google Doc and the lesson is spelled out for them very clearly. It tells you this is what you're going to do in the lesson. This is what we hope that you've learned. And then say for lesson 1, it says, instead of watching, it says watch this CDC slideshow. So they click a link and then they see the United States get darker and darker. So everything is turned into the roadmaps for students. Now for homework sheets, we turned all of the homework sheets into Google Forms. So the roadmaps link to the Google Forms. And the hardest thing about using this curriculum in class is that you need to actually build the hyperlinks between your Google Docs and your Google Forms. So for example, lesson 1 roadmap needs to be tied to student sheet 1, and lesson 2 roadmap needs to be tied to student sheet 2. And by doing this, by taking this folder, making a copy of everything in there, tying it to your own student sheets, when your students fill out their roadmaps, their data is dumping into your own folder. Then you can open up those student sheets and see who's responded and when responded. You can edit this however you like. It is yours to take and keep and run with. If there are things that you don't like, take it out. If there are things that you want to put in, put it in. It's all for you to do however you would like to do, unless you're participating in our research study, and then you pretty much have to teach it as written so that we have some fidelity of implementation. So thank you for your time and energy. I'm not sure that we have time for a Zoom room after this. Please contact me if you have any questions. If you would like to teach this and you are confused about the whole Google folder thing, let me know. If making the hyperlinks is beyond what you can handle right now, which is would be no surprise, I would be happy to do that for you if you just let me know. Thank you for your time. As I mentioned, I will have a slide up with all of the links that I have talked about so that you have direct access to those, and enjoy the conference.